Alright guys, a few comments on the quiz. I have two that I did not get graded before. I apologize for that. They'll be graded before midnight tonight, and then after that everybody will be able to see what they got wrong. As a matter of fact, I'll go ahead and open it up for you to do that, and then we'll have another week in order for you to do the retake. A couple of comments. If I say please leave out all spaces to help the autograder, I appreciate those of y'all who leave out the spaces to help the autograder. What does that mean? Store the value 10 in C. C equals 10. That'd be one way to write it, or you could do that. Or, you know, you want to be nuts. That's correct. But D2L marks that as wrong, and I have to go back in and change it to be correct. So, for those of y'all who abided by the please leave out all spaces to help the autograder, I give you thanks. However, a couple of folks started redefining their variables every time. So store the value 10 into C. C is already defined, so we don't need to type in int there. And if you are going to type in int there, I might have accepted that, but you really do have to put the space there then. So just because I say please leave out all spaces doesn't mean create a syntax error. If the syntax looks weird, you know, that would not compile. Go ahead and put the space there. But in this case, we didn't need to redefine all the variables. Now, I actually didn't count you off on that, and the person who did that, except in one case. And I'm going to, well, I can't show you. Let's see if I can get to it. Pooh. All right, I can't find it, but it was supposed to be something like this. B equals B plus 1, or B is equal to B minus 1, or something like that. If you gave it a variable type right there, that would not work at all. Why? Because how could we increment B if B had never been created before? So on the other ones where you added the word int where it wasn't necessary, I gave you credit for it, or double or whatever, even though you didn't have the space there. But in that case, I just had to say, no, that wouldn't work. But that's why. So guess that's enough to say about that. Anyways, let's make sure that you can all get into your quiz. Those of y'all who did get it successfully graded. Okay, so if you go to quizzes, you'll see the list of quizzes. You pull down on the little drop down, you see submissions. You can pick your submission and go through and you'll see which ones you missed. And then you can use that information to retake it. Can everybody get to that page? Those who actually have it graded. Two of y'all do not, but other people, can you get into that screen?
Can we go into it as many times as we want, or just once?
You can take it twice.
Okay.
Right, you'll be able to take it a second time.
No, wait, when we want to go and see which one.
Oh, you ought to be able to view it as many times as you want. Yeah. Not like you better print it out now or forever hold your peace. You'll be able to get back into it. So we were done with chapter 2. So expressions and interactivity. The CIN object lets us get input from the keyboard, and we've already been using CIN, so I'm not going to dally long on these slides. So the way you do it is you type in CIN, and you have two arrows leading away from CIN into the variable that you're reading in. This is actually known as the stream insertion operator, if we're going to give it a funky name that you'll never say again. I just call it arrow, arrow. If you have C out there, the arrows point towards C out because stuff is going out. If you have C in, then the arrows go away from C in because they're going into the data. So input is stored into one or more variables. Typically you'll write something like this, CIN into X, right? You could also do this, CIN into X and into Y. Are you going to ask for more than one piece of data at the same time? Not necessarily, but you could ask the user, please enter your first and last names. In which case it would look something like this, Cout, please enter first and last name. That's going to make the people who have, like, 3 after the names, a third or whatever, unhappy. They won't be able to enter all of them. And then we could do CIN into the first name and into the last name, like that. I don't usually mess with that. Usually I just ask one question and let them type in one answer.
How do you put a space between the first and last name?
That's if you're printing. Good question, though. That's a quiz question. Very good question. Let me close this. So if you have this is definitely one of the quiz questions. String first name is equal to Bob. String last name is equal to Roberts. And I think I had different names for the variables, like F name and L name or something like that, but it's the same idea. And you want it to say when it runs, my name is Bob Roberts. There's a lot of things that can go wrong. For one thing, you could do this. Cout, my name is Bob Roberts. And that's when I pass out. Don't do that. Use the variable declarations. That's why I said up there, using the variable declarations. Okay, so we're not going to do that. Instead, we're going to do Cout, my name is, followed by a space because we want that. Then we need to do arrow, arrow, their first name, whatever it was called, FN or F name or whatever. A couple more arrows so that we can put our space between them. I don't remember if we were supposed to put on an exclamation mark or not. But like that. Why did we need that space there? Because without it, the output would look like this. My name is Bob Roberts. So if we took that out, that's what we would get. Right? Because it's putting first name and then there's nothing else and then the last name. So we definitely do need that space there. So you just tack on a couple more arrows in a space like that. Does that make sense? That'll do that. So we're good now? All right. Let's So CIN will convert data to the type that matches the variable. And that makes this language rather odd for those of y'all who've already learned Java, where you can't get away with this, or Python, where everything that you read in was a string and you had to convert it. CIN will auto-magically convert into an int or a float or a double, whatever the data type is. That doesn't mean you can type in something completely wrong. If it says how tall is the room and they're trying to store it into an int, you better not type the word Bob, right? That's not a number. CIN is not going to be able to convert Bob into a number, and the program is not going to work at all. So displaying a prompt. What a prompt is it's a message telling the user what to type in. Tell the user what input is expected. Things like enter your age, right? What is your last name? Those are all prompts. So typically what you do is you see out your prompt, blah, 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 whatever it's going to be, and then you CIN back into a variable. And of course you put some real good stuff here, and you give a good variable name there. So example, cout, what is your age? Cin into an age variable, like that. Now if we have age there, we better have defined it previously. So up above that statement, somewhere up above in main, we'd better have declared age, either as a double or as an int. Oh, reminds me of another test question, quiz question. The last one, although when you take it again, the questions may be sorted randomly, so you may see a different question as the last one. What data type do you use for a floating point number larger than 1e? I think it was either 34 or 37. I forget which. Lots of people chose long int. Long int is not correct because an int is not a floating point number. Integer means whole numbers only. Floating point means that there's a decimal involved, like 1.34. Right, that's a floating point number. That cannot be stored in an int. So long int was the wrong answer. Double is the right answer. So generally your rules of thumb is if it's smaller than 2 billion and it's a whole number, otherwise use a long int. So a long is for numbers greater than 2 billion, whole numbers greater than 2 billion. Floats are floating point numbers less than 1e to the 37, or was it 34? I don't remember. The reason I don't remember is because I'm always going to use double. Double is for floating point numbers greater than 1e to the 37. And they're the default data type, actually, so you may as well just use them. If you type in a constant, if you start to say age is equal to weight divided by 1.3, C treats that as though it were a double, not a float. So just make all your floating point variables double, no matter what the book says. So you should always pair a cout with a cin, usually. Because the user has to know what to type before they can type it. If the screen just comes up and it's absolutely blank and it's sitting there, well, maybe they know what to type. Probably not, so you should prompt them with a message. You can use cin to read in more than one thing at the same time. We may as well play with that, even though I'm going to recommend that you don't do that. So I'm going to go ahead and load up Visual Studio and make a project. So this is a C++ empty project, September 19. And then over in source files, add a new source file. Source.cpp is a good enough name for it. Good old boilerplate. I'm not going to even read it aloud. But my new fully pumped up and perfect version of the boilerplate now also includes string and math, C math. Then our using namespace std. And then our int main parentheses end parentheses. And for your PC users, not your Mac users, system parentheses quote pause. All right, I'm going to declare a couple of variables. Strings. String fn for first name, except I'm going to make it a capital F. Just because I don't like lowercase l, it looks like a 1. So string fn, comma, ln. Now let's ask the user for their name, their age. No, let's ask them for their name. Enter your first and last name. And then CIN into FN, and also arrow arrow into last name, LN. And now let's see out what they just typed in. Your name seems to be arrow arrow FN arrow arrow followed by a space. Followed by last name, followed by an exclamation mark and a backslash n for ENDL. Just a sec. I think I got it all on there. All right. Something interesting to try is when you run this, rebuild solution, and then, do I have an error? Nope. Although it says enter your first and last name, Bob Roberts, your name seems to be Bob Roberts, you don't have to enter both of them. Bob. But now it just sits here. It's waiting for me to type the last name. What if I don't know that and I start hitting enter over and over, getting frustrated? And then I remember, oh, it wanted the last name too, Roberts. It still works. So what the arrow arrow, CIN arrow arrow is doing is it's, quote, tokenizing the input. Tokenizing means it's ignoring all of the so-called white space. What is white space? It's the tab key, it's the space bar, and the enter key. So I could do this, Bob, followed by a whole bunch of tabs, Roberts, and it says your name seems to be Bob Roberts. Or I could run it and type, you know, a whole bunch of tabs and then type in a Bob there, you know, and then a whole bunch of junk and then a Roberts like that, and it still works. So tokenizing, what CIN is doing is it's looking for the first non-blank piece of information, and then that is passed into the first variable after the CIN statement. Remember where it said CIN arrow arrow FN? The first non-blank piece of information gets stored into FN. But we had two variables. We had two variables listed. We had LN as well, right there. So it kept looking. It kept waiting for us to type more in. And so it kept scanning, and it finally found the next so-called token, the next non-blank piece of information. Sometimes you don't want it to do that. What do I mean by that? What if you wanted to be able to type in a name that might have a middle name, it might not have a middle name. Some people have like 3 or 4 middle names. Some people have junior or senior or the third or whatever after their name. You wouldn't know whether you needed to do arrow arrow name 1, arrow arrow name 2, arrow arrow name 3, arrow arrow name 4. You know, you wouldn't know how many names, how many pieces of information in advance. In that case, you'd probably want to do something that would get the entire line. And that's something different. We will talk about that at a future point. For now, we're just using CIN to read in single pieces of data. And I really don't recommend this syntax, except for something really closely, tightly paired, like first and last name. People have that idea, right? But then if you ask them for their age and then their weight, would you want to do that in one prompt? No, people are not used to having to type in their age, 34, and their weight, 175, all on one line. So I wouldn't combine those. In general, I don't take advantage of that. The order is important. The first value entered goes into the first variable. So since I keep typing Bob as the first thing and Roberts as the second, The first thing I type goes into fn. The second thing I type goes into ln. And notice that our space has to be there again, just like on our quiz question. And so CIN will automatically convert the data to the data type that it wants. But if you type in something completely incompatible, it won't be able to do that. So let's add another question. Cout, what is your age? Now we don't have an age variable yet, so I can't do this. I can't type in CIN error age. It's going to tell me that age is not defined. So I need to go and create an age variable. It's going to be a number, so I could either make it an int or a double. Most people type in their age as whole numbers, right? They don't say, okay, I'm 37.3 years old. So why don't we make age an int? So that's what I added. Int age, cout, what is your age, CIN into age, and now let's use that data for something. Int DA for double age is equal to age times 2, and then let's tell them what double their age is. Cout, double your age is, followed by DA, followed by ENDL. All right, first I'm going to type in good data. I want to see it work. I need to close my currently running version of the program. So my first and last name, Jimmy John. My age is 34, and it says double your age is 68. Thank you, Mr. Computer. Now I'm going to run it again, but I'm going to type in bad data. What is your first and last name? Well, my name is Jimmy John. My age is, I don't know. All right, and it says double your age is negative 17 trillion. Okay, you can see that that did not do anything worthwhile. At least it didn't flat out totally crash, which it would have done in Java with a red error message, but we didn't get any valid data out of that. But CIN otherwise does its best to convert the data that they have typed in into the format that you are asking for. So when we do CIN arrow into age, it tries to convert it into an integer. Meaning that if they type in something with an exclamation mark, with a decimal point, a floating point number, let's find out what happens. I am one of those weird people who measure my age down to the third decimal. So my name is Bobby Johns, and my age is 43.21. And it says double your age is 86. So what did it actually store in the age variable? Right, it didn't store the 0.21. It tried to, but an age is an int, so it can only hold whole numbers. So it just rounded it down. If I typed in 39.9999999, it would still round it all the way down to 39, not up to 40. Mathematical expressions. A mathematical expression is a sequence of one or more operands and operators, or a sequence of values and mathematical symbols, like that. The asterisk is an operator. It's the multiply operator. And so it has, each asterisk takes two operands, values that it works on. So going left to right, this is an operator right here, 2, and pi. Those are the operands for this operator. Operands are the pieces of data that the operator works on. And I know that I'm going to twist my tongue if I say that too often. So what it does is it solves 2 times pi first. And it gets, 6.28, whatever. And then we have another multiply. And so the result of that one, 6.28, whatever, blah, 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 and this one are multiplied together. So now that is our operator, and the operand is this, and the other operand is that calculated value from that. So a mathematical expression is a sequence of mathematical operators and values. So the expression can be literals, it can be variables, or mathematical combinations of constants and variables. Strictly speaking, even this is an expression. But it's not a very interesting expression. Also, strictly speaking, that is an expression. But more commonly, you use the term expression to mean a series of things, not just one, right? You don't consider 3 a mathematical formula, but you consider 3 times 4 plus 5 a mathematical formula. So if you think of expressions and formulas as kind of interchangeable, except there are other kinds of expressions other than math. So some simple expressions and their values. These follow the rules of PEMDAS. Please hold a thumb up if I've talked enough about PEMDAS. All right, so to solve this, if we were going to drag this out to the side so you couldn't see the answers, do we do that first? Times or plus? All right, so 2 times 4 is 8 plus 5. What do we do here first? Division. So 10 divided by 2 is 5. These are both integers. So if it ended in a 0.5, we would round down, but it doesn't. So 5 minus 3 is 2. We'll just skip to this bottom one. What's the first thing we're going to do here?
3 times 2.
Yeah, so 6 minus 6 is 0.
So
Plus 7 goes back up to 7. The minus 1 is down to 6 again. So if we have the equation for pi r squared, but expressed all pretty like in a word program, and then you had to write that into an expression. Area is equal to 4 pi r squared. You can't just make it think that because two things are next to each other, they're going to get multiplied. So this would be the wrong answer. That would be the wrong answer. We're getting there, though. This would be the wrong answer. Why? Because it's not going to assume multiply. Book writers, and when we're taking our notes, we can get away with leaving out the big X, the big times. But in computerese, we can't. We have to put our multiply operators. That would be correct. That's 4 pi r squared. And if you felt like using parentheses somewhere to make it look prettier, you could do that.
How do we do the to the power 2?
You can't in this language, but you can use the POW function. We could do area is equal to 4 times pi times power of r to the power of 2. Python has that. If you want to say, 6 squared, you do that. This language doesn't have that, so you'd have to do POW 6 to the power of 2. Does that make sense? Yeah. Okay. So when you're creating an expression and you're reading it from a book or you're reading it from an assignment I give you or a quiz question or whatever, just remember you have to put all the multiplies in there yourself. If you typed it into code and you left them out, it wouldn't work. And just putting things in parentheses next to each other doesn't imply that a multiply is going to happen there. You actually have to put it there. So everything we've been talking about so far is what's known as a binary operator. Binary, meaning that it has two operands, x plus y, 1 times 2, 3 minus 4, 6 divided by 3. They all have 2. There's also the unary operator. And I think this is stupid, but we got to talk about it. The minus sign, what does it do? It takes the number that follows it and flips it to negative. So, -7. We think of that as being one number, right? But to the computer, it's actually two things. It's a number preceded by a unary operator that makes it negative. So the computer treats this as though we had just written 0 minus 7, or whatever. It takes this number and it flips it to make it negative. Am I going to ever ask you what the unary operator is? No.
Does the plus do the same thing? Does it count as another one?
Well, plus actually does addition, and it won't give you a problem usually. All right, I can't say that. Let's go play with that and find out. If I do this, age is equal to +3. Is it going to count that as an error, or is it going to say it's good? It may say it's okay. In which case, yeah, that is true. What do you know? So plus will do the same thing there. Along with the binary and the unary operators is the ternary operator, and that's the question mark. All right, now I'm having really strong sense of deja vu. Have we done the question mark? It looks like this. Suppose we have asked the user for the temperature. T stores the temperature. And we are going to print whether something is hot or cold. We could write it like this. If T is less than 50 degrees, then the result is equal to hot. Else, the result is equal to cold. No, I have those reversed. Okay, so if T is greater than 100, how about that? If T is greater than 100, it's hot, else it's cold. My T is cold if it's not more than 100 degrees. You could rewrite that in a short form like this. And I'm going to put parentheses where they're not required just because I think it makes it easier to read. Is T greater than 100? Question mark. If so, it's hot, else it's cold. So we have replaced these four statements with that one statement. So this is called the ternary operator because it actually has three terms. It's got a condition here, and it's got a value 1, and it's got a value 2. So the syntax of it is condition, question mark, value 1, colon, value 2. And what happens is this gets evaluated. And if it's true, the first thing goes over here into result. But if this is false, the second thing goes over here. It's worth a point on the exam. Do you have to use it in your code? Nah, but if you're looking online, people will use this just because it gives you compact looking code. This is easier to read, right? After you've looked at it often enough, then this would be about as easy to read if you use it. And like I said, those parentheses are not necessary. I just like them there to make them easier to read because the syntax is not real clear, right? That if somebody threw that in you on day one, you would have no idea what that was doing. But now we do. So that's the ternary operator, also known as the conditional operator. Ternary because it takes three pieces. It takes that piece, and that piece. The question mark. So if T is greater than 100, hot gets copied into result. Else, cold. Let's go back to our program and make use of that somehow. So let's see out. Age is less than 18? Question mark. Too young to vote. /n followed by a colon. Followed by go vote, exclamation mark /n. Now that just makes it as hard as I'll get out to read, in my opinion. But what's it going to do? It's going to check their age, and if their age is less than 18, it's going to print too young to vote. Otherwise, it's going to print go vote. I'll bring it back just a second. Ooh, it didn't print anything at all. How about that? I'm going to change this a little bit. I'm going to take that C out away and make this say string S, just S for string, is equal to all of that stuff, and then I'm going to C out S followed by ENDL, like that. And I'm going to take out these backslash n's to get them all to fit on the same page. Now I hope it works. No, it did not. I have a new line and a constant. I do indeed. Alrighty. If something's that hard to type, then it's probably not a very clear way of doing it. But to an experienced programmer who would use the conditional operator a lot, that would make perfect sense. Oh, you're checking their age and you're storing one of two possible results into it. Either too young to vote or go vote. Okay. So you had a question?
Oh, never mind. Thanks.
You can ask anyways, even though I answered it. No,
Cool.
I'm kidding.
So why couldn't we have the whole thing on the C outline?
I am not totally sure. I think we would have been able to get away with it if I had done this. If I had copied this entire shebang and put that inside parentheses to force it all to happen first. I think that would have worked. Don't make this change, guys. That's making it even harder to read. Okay, that did work.
Okay.
So what those parentheses do is just like in a math equation, it forces this to be done first before anything else happens. And so apparently that string needed to be calculated before anything else happened. Cool. But I'm going to change it back to how it was. And again, are those parentheses necessary? No, so I can remove them. Do I think it make it easier to read? I sure do. So I'm going to add them back. So associativity. Associativity says whether something is processed left to right or right to left. And the slide is wrong. Good thing I'm not going to ask you the definition of associativity. Unary negation goes from right to left, whereas the rest of them go left to right. Right? Because we add these two numbers, and then we do that, and then we do that. So within the same precedence, according to our PEMDAS, we go left to right. Moving right on. So we can group with parentheses to force certain things to happen first. And y'all already know how to do that. So algebraic expressions. We want to write this. M is equal to y2 minus y1 over x2 minus x1. We're going to have to group these parts in parentheses. So that's what we've done here. y2 minus y1 divided by x2 minus x1. If you left off the parentheses, it would give you the complete wrong answer. And y'all probably already are familiar with that idea from using your calculator in math or science classes. But if you have an expression and it's got more than one term on the top or the bottom, you better use parentheses to group them. When you mix apples with oranges, type conversion. The computer will only do math between data of the same type. It can only add integers. It cannot add an integer and a floating point. And it cannot divide a floating point by an integer or an integer by a floating point. That sounds really stupid. Well, man, computers are dumb. Yeah, they are, but the language tries to compensate for that. The reason why that's true is because integers are stored in a completely different little bit pattern than floating point numbers. Integers are just like we did with all those zeros and ones, and I'm still thinking I may have skipped a lecture on y'all that I need to go back and hit. Whereas floating points are stored as two pieces, right? They have a number and then they have an exponent. The first number is called the mantissa, and the second number is the exponent. So if you say 3 to the times 10 to the 6, the 3 is your mantissa and your exponent is a 6. Well, that's not an integer, and so the computer processes that in a completely different way. So if you're adding x and y, did not mean to hit that. I'm going to use different letters. If you're adding I and D, if I is an int and D is a double, a floating point, the computer can't add them together. However, the C++ compiler fixes that by converting the wimpier type to the stronger type. Meaning that it won't do, it'll convert it to the format which is compatible with both. If we try to put a double inside an int, that's a bad conversion, right? So that won't work. But it's safe to put an int inside of a double, right? Because an int is small, less than 2 billion, and a double can hold up, to exponent e, or 3 times 10 to the 340 or whatever. So I will get converted to a float, to a double, before the math is done. The compiler writes all that code inside it so that that happens. That's called promoting the data, promoting it to a higher type. And then there's a list of data types, with int being down here at the bottom, and there are even smaller ones than ints. There's short and byte. But then above int, there's the long. Now that's the hierarchy of the integer types, and then there's floats, and then there's doubles. Now a byte can be converted into a short, no problem. A byte is just a value that goes up to 255. A short is a number that goes up to 655,000, more or less. An int is something that goes up to about 2 billion. And long is huge. Anyways, larger value. So if we tried to multiply a long by an int, the compiler would provide the code to convert them both to longs. If we tried to multiply an int by a short, the compiler would promote them both to be ints. Because if you go the other way, you risk losing data. A byte can't hold a value larger than 255. So what if we entered the year 1976 and we tried to, convert it into a byte in order to do some math? Well, 1976 won't fit into a byte. It's too big of a number. So converting up the chart is fine. It's called promotion. And it'll do that automatically. Usually what happens is you see conversions between ints and the floating point types. And since floating point types have exponents, they can hold really large values. Any one of these 4 types will fit into a float. And they all will fit into a double. So if you do this, 3 times 4.4, and you want to print that out, here's what the computer does. It goes, okay, I have an int, cool. Oh, I have a floating point, it's a double. I'm going to have to convert them both to be the same data type because the computer doesn't know how to do math on mixed data types. Is it safe to convert 4.4 to an int? No, it's not. That would be demoting it, causing probable data loss. You'd at least lose that 0.4, and it might be too large to fit in there at all. So instead, the conversion, the implicit conversion that gets provided is to up this int to be a double. and then they're both floating point types, and then the math happens just fine. So implicit casting, or conversion, is when the compiler will convert one data type to another automatically. So these kinds of conversions are safe. Going up the hill is safe. Going back down the hill is not safe. So let's see what the slide has to say about it before I start babbling any further. If the operands are not of the same type, C++ will convert one to be the type of the other, which can impact your calculations. So here's the hierarchy. They throw in a couple extras, unsigned long and unsigned ints and stuff like that. But just remember, doubles are bigger than floats. Floats are bigger than longs. Longs are bigger than ints. So type coercion. Aha, see, I said it was called implicit casting. That's the other textbook. Type coercion is the automatic conversion of an operand to a data type. Promotion is going up to a higher data type, which is always safe. You don't lose data through promotion. Demotion is converting to a lower data type. Let's do a little bit of demoting. We're going to go over here into our program and ask them to type in a really big number. Enter a number larger than 2 billion. I put the wrong arrows on that, and I often do that. Why do I need to make the arrows go towards cout? Because those are the arrows that you use with cin. The arrows have to point towards cout. So, did that wrong. So now I'm going to let them type that in. I need two variables. I'm going to make one called d for double and one called int for I. I'm going to read what they typed in into d. So I do cin arrow arrow d. But let's also try to store that into I. So let's say I is equal to d. That'll probably give us a warning message at the very least, if not an error message. We'll find out when we compile it. A Java compiler would just flat out refuse to compile it. Why? Because we're trying to convert a double which cannot fit into an int. I believe the C++ compiler may frown upon it, but it might work. But let's give it a shot. Now let's write out those two values. Cout d equals, end quote, arrow arrow d, arrow arrow endl. And in cout, I equals arrow arrow d, arrow arrow endl. Kill our program and run it again. My first name, Bobby Bob. My age is 12. A number larger than 2 billion. Okay. 3, 4, and I'm going to type in 12 zeros, so it'll be in the trillions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I made a really dumb mistake. Looking at my code, can you see a problem with it? The behavior is that it printed both d and I as being the same exact thing. And what's worse is that since I is an integer, it shouldn't be showing a decimal point here. So with that evidence, what did I do wrong in my code?
You have an I above it.
Right, it says I equals, but then I print out d. So I correct that act of genius and run it again. Twelve zeros again. So look what happened. I typed in 99 trillion or whatever, and it did store that accurately in a double. But then when I forced that double to try to fit into an int, it just flat out didn't work. It just kind of lost its mind there. Negative 2 billion is what it decided that was equal to. And it's obviously not equal to 2 billion. So that's why some languages won't even allow that kind of conversion without a special word in front of it, because you have data loss. If you're converting from a double to an integer, if we typed in a small number, it'd work okay. Go ahead and run it and type in a number less than 2 billion. It'll work fine. Enter a number smaller than 2 billion. Okay, how about 9,000? See, that works. But that's because the coercion of the data from a double to an int did not result in something that was too large for the int to hold. So whenever you do something like this, whenever you tell it to go from a larger data type to a smaller data type, whenever you force a demotion of data types like that, you run the risk of data corruption, of numbers getting hosed, the way you just saw that. Technically, that's called overflow. It's when the bits, you have more bits than you can store in that data type. An int is a 32-bit data type, a double is a 64-bit data type, so we have too many bits to fit into the I. So if it's larger than 2 billion, it's going to be corrupted. So coercion rules. I'm done talking about coercion. Alrighty. Overflow and underflow. This occurs when a value gets too large or too small to be held in a variable. Let's write something that will demonstrate overflow, and then I think it'll be the last thing we do today. Say you were just doubling a number over and over and over, right? 1, 2, 4, 8, 16, 32. We're going to do that in our code. So I'm just going to write a loop. Not that we've talked a lot about loops, but I'm going to write one anyways. We need a variable that we're going to keep doubling, and I'm just going to reuse that I variable. I is equal to 1. I didn't choose 0 because if you double 0, it's still going to be 0. So let's see out a message. Type 1 to double. And let's read that in. Doesn't matter what we read this into. CIN. Now let's double our value. Let's print it out. So C out. Let's do I equals I times 2, and then let's C out I equals, followed by that variable I, and then arrow, arrow, E and DL. I guess I should have just doubled their age over and over. We'd already doubled it once, huh? So anyways, run the program and keep typing 1 to double it over and over and over, and watch the number get larger and larger, and watch what happens when it gets larger than 1 billion, which will take a while, but it won't take too long. After a certain point, you will see it switch from being positive to negative. You may have to double it 16 or 31 times or something for that to happen, but you'll hit the point.
Then it goes to 0.
Yeah. So it's completely messed up at that point. That's called overflow. And the reason what happened is we have a certain number of bits that can hold a number. We exceeded the number of bits that were allowed because remember I said that an int can hold a number of about 2 billion? Well, here at this point, int holds 1 billion. If we added commas, it'd be real easy to see. And then when you try to double that, it was larger than that 2 billion. And it couldn't fit in there anymore. And so it just messed it all the heck up. And so we got our negative number. And then we tried to double that again, and I guess it just completely gave up and went to 0. That's called overflow. That's putting too much data. Underflow works the same way. If we kept subtracting data from it, you know, we might get up to negative 2 billion, and then it might flip over and turn into an incorrect positive number. I'm definitely going to have to do that lecture on bits and bytes and stuff like that. I know I keep brushing up against it. I guess we'll do that on Thursday. And that'll just be a warning for any of y'all who have sat through this lecture for Python and scripting and 1193, is that on Thursday we're going to talk about bits and bytes. You know, you don't have to come in and do it. I'll show you mercy. Okay, so that's overflow. A value is too large to be held in a variable. So the variable contains data that is, quote, wrapped around the set of possible values. And remember in old video games, usually your character would walk up and he'd hit a wall and he'd just stop. But then some people make games where the spaceship flew off the edge, he'd come right back on the other side. Right? It's kind of wrapping around. That's kind of what's happening to the data, except in a bad way. So different systems may display a warning or error message. They may stop the program. Or worse, they may continue without telling you that anything is wrong. And C++ does that. Hey, no problem. You doubled that value too many times and it's now equal to 0. I'm not going to care. You know, I'll go ahead and calculate the national debt like that. Hey, you don't owe anything anymore. So that is a concept of overflow. If you are going to do data conversion, we're stopping here. We're just going to flat out stop right there. Let's see what we need to do as far as homework is concerned. All right, so the homework is actually, for the people who just sat through the Java lecture, the same thing that we just did in Java. But here's what we're doing. We're going to write a program that's going to ask the user for the diameter of a sphere in feet. How big is a sphere? Is it 1 feet wide? Is it 10 feet wide? Is it 0.1 feet wide? And here are just some values to play with. A marble happens to be that many feet wide. A basketball happens to be that many feet wide. These are just sizes to try. And we're also going to ask them what kind of material they are using. Is the ball made of ice, or is it made of aluminum, or is it made of gold? And so then when they run it, it'll give them the answer. I'm going to demonstrate that. It's got 2 pages of code. It's got Java code, and it's got C++ code. And it's totally okay just to grab all of this text inside the C++ version and paste it into your code. Like that, and then run it. And so this is what it looks like when it runs as you copy and paste it. But that's not all the assignment is, of course, right? It's not just copying and pasting. We're going to actually run it. So it'll ask, what is the diameter of the sphere in feet? It's 1 foot. What is it made out of? It's made out of ice. And I forgot to put a system pause at the bottom, so I didn't get to see the results. So system pause. Let's do that. Anyways, you're going to run the program. You're going to copy and paste it, or you're going to type it in. And then you're going to make some changes that are asked in the instructions. So diameter of the sphere is 1, ice, aluminum, or gold. I want it to be made out of ice. It weighs 28 pounds. I'm going to run it again, and that sphere is going to be made out of aluminum, and it's going to weigh a lot more. 87 pounds rather than 28. I'm going to run it once more. The sphere is going to be made out of gold. And it weighs a lot, almost 700 pounds. So gold is very much heavier than aluminum. Aluminum is an almost magically light metal. So what are you going to do once you get that code typed in, or you copy and paste it? Is you're going to follow the rest of the instructions, which are change the application to support more than just ice, aluminum, and gold. It also needs to support iron, cedar, soil, paper, and osmium. So if you go look at your program, there's a place up here where it's displaying the different kinds of materials. Enter 1 for ice, 2 for aluminum, 3 for gold. Well, we could tack some more things on there, right? Enter 4 for, I don't remember all the metals, all the materials now. For wood, 5 for soil, whatever, Just put all of them that you need to have, and then put some \ns if it makes it easier to read. Then there's a big if statement down here. If type is equal to 1, that's ice. And so we would look up the density that's on our chart. Ice is indeed 55, and aluminum is indeed 168. So you'd go back into your code. All right, aluminum is 168, gold is 1203, but now we added some other kinds. 4 was supposed to be wood, so else if type is equal to 4, then the density is equal to whatever the instructions say the density of wood is. And I know that I did that wrong. Iron. Iron was supposed to be next, followed by cedar, and so on. But anyways, so just make an if statement that matches the number they type to a density. And so all you're going to have to do is add on a couple of print statements and then 5 extra if statements. Else if choice is equal to cedar, density equals 22. Else if choice is equal to this, density is equal to that. Then if you feel like it, make the program loop until they've entered a negative number. But that doesn't sound to me like something that we've done a lot of yet, so if you feel like ignoring it, that's totally fine. Does that make sense? Take the code, add the extra densities, and add the print statements that'll support it so that they know that they can choose iron, cedar, or soil, or paper. Alrighty, hope that's not too bad. So I think we're done. Let's go ahead and make a drop box for today. All right, there's a drop box now, H. All right, for those who cared, I modified the program very slightly so that it was doubling the age rather than I. You don't need to make those changes, but they'll be up there in the notes. All I did is I removed that int I business, and instead I made it all based on the age. Should have done that to begin with. All right, guys, once you get the CPP file uploaded, then we're done for today, and I'll see you all on Thursday.